Anthrax. Okay. Anthrax is a disease of the lung and the skin. Okay. If it gets in the lungs, it's easy for Bacillus anthracis, the causative agent of anthrax, to cross the epithelial lining of your lungs and get into the capillaries and get into the blood. Okay, whether it's skin, Bacillus anthracis got down into the pores. We talked about this in the skin disease chapter. Gets down in the pores, is able to get below the epidermis into the dermis, subcutaneous, gets into the blood. Either way, septicemia with Bacillus anthracis is a possible outcome. Okay. Once it gets there, it can spread throughout the body. For a long time, anthrax was thought of as a zoonotic disease. Okay. Exposure, it was due to herbivore livestock, cattle, sheep. It was, people on farms were exposed to it. This anthrax, Bacillus anthracis, the disease, what we now know as anthrax, was one of the topics, one of the organisms that Robert Koch studied as he was developing his four postulates model back in 1877. Pasteur was the first to come up with a vaccination for anthrax. Anthrax was widespread, okay, because remember, even at the beginning of the Industrial Revolution, cities, you had really tight, urban areas, but then you had lots of sprawl. Before subdivisions, you had a lot of rural people living out in the rural areas or working there, so exposure to anthrax was still quite high. Cutaneous or pulmonary, okay, skin or lungs, are going to show different symptoms. There's also ingestion, gastrointestinal anthrax. Somebody eats or ingests Bacillus anthracis. Remember, Bacillus anthracis, the causative agent of anthrax, is one of our bacteria that we've talked about that forms endospores. So if you ingest the endospores can germinate in the small and large intestine, and the toxins they produce will be absorbed into the body that way. For us adults, our digestive system, our stomach, our small intestine, are environments that damage the endospore enough that it can't germinate. But this is the reason why they tell mothers not to feed infants under the age of 2 honey, because the honey will have dust and endospores that will germinate and will allow Bacillus anthracis to colonize the small intestine and the large intestine. We find that the cutaneous and the pulmonary forms are the most common. Okay, either way, cutaneous or pulmonary, once it gets into the blood, death, it's usually the result. Okay, high mortality rate due to the septicemia overwhelming our immune response, overwhelming being resistant to most antibiotics. If we're talking pulmonary, okay, anthrax gets into the lungs, the bacteria will grow, colonize, and get into the capillary beds. As it's colonizing, it is actually leading to inflammation. So the presence of the bacteria is causing inflammation, and the bacteria itself is damaging tissues. All that together is going to lead to hemorrhaging within the alveoli. So patients who present with pulmonary anthrax will actually start coughing up blood and lung tissue. Problem we have with treatments of Bacillus anthracis is that since it's an endospore former, in the presence of antibiotics, some of these bacteria will form endospores. Not all of them can form endospores fast enough that the antibiotics will be useless, but if you can only wipe out 99.9% of the bacteria in the blood, that 1/100th of that 1,000th of 1% can still reestablish the blood infection. The blood infection. Exposure, a lot of times, is going to be breathing in dust. Since Bacillus anthracis originally is considered a soil bacterium, if you're out, you're breathing in dust that is actual soil particulates, there's a good chance you could breathe in Bacillus anthracis endospores. Now, why isn't everybody coming down with anthrax? Well, because your nose has the hairs, the sinuses have the mucus that will catch the endospores. You either sneeze them out, or as this mucus drains down into your stomach, you digest the endospores away. Has to be very small particulates that can make it past the hairs, past the mucus-lined sinuses, down through the nasopharynx, past the bronchi, bronchioles, into the alveoli, to begin germination before you can get anthrax, pulmonary anthrax. What's quite damaging about anthrax, whether you're talking cutaneous or pulmonary, once it gets into the tissues, it starts making what is referred to as a tripartite toxin. Three-part toxin, okay? That's where its name comes from. And it's an exotoxin, so it is a purpose-built weapon. Okay? A purpose-built weapon that will lead to massive inflammation. Okay? More inflammation means more swelling of the tissues, more white blood cells showing up, doing indiscriminate damage, which means leads to rearrangement of the architecture of the tissue, which ultimately could allow for Bacillus anthracis to survive better. Not only does Bacillus anthracis make the tripartite toxins, they also have the genes for making hemolysin. Remember, hemolysin's lyse red blood cells. Red blood cells are nothing more than floating bags of nutrients and amino acids as far as the bacteria are concerned. They also can make enzymes that damage host membranes, cause the epithelial cells lining the lungs to burst open. Out comes all the amino acids and sugars and everything else. It's a facultative parasite, okay? Facultative means it can grow in us, or it can grow on its own, okay? It's not obligate, okay? Other microbes we could talk about, chlamydia, pneumonia, and things like that, are obligate parasites. It must be passed host to host. Here, this Bacillus anthracis, it can grow in us, or it can grow in the soil. Either way, back and forth, does not matter. Domesticated animals get infected while they're out grazing, okay? They're out grazing, there's dust, they're coming to contact with soil, and the smaller the dust particles, the better chance that those dust particles have of getting into the pores. Yes, even cows, even goats have pores. So do the farmers. So you can get cutaneous skin infections that way, or you breathe it in. Okay, you breathe in the dust. You get pulmonary. Humans get it. Domesticated animals can get pulmonary also. We're starting to see that it's shifting. Who's getting exposed? Textile workers, as they're working with more natural fibers, or we go back to working with the natural fibers. In some areas, in some industries, they're getting away from the synthetics. So they're working with goat hair and llama hair. Well, on the goat hair, on the llama hair, it's going to be dust. There's going to be soil. In that dust or on those soil particles is going to be endospores. It's hot. It's sweaty work. As you heat it up, you're sweating. Pores open up. Dust, dirt gets down to the pores along with the endospores. Next thing you know, you have those small little ulcerations that we attribute to cutaneous. As they're also working, they could be breathing in dust and whatnot coming off the fur, coming off the hair. Chance of pulmonary. Anthrax has been weaponized. The strains that are used for the weaponized versions of anthrax have been developed to form endospores that do not clump together. Okay, remember, the smaller the particles, the better the chance it gets down to the alveoli. Well, natural occurring Bacillus anthracis will clump together, clumps of spores on larger particles of dirt, larger particles of soil or dust. Those are going to get trapped. The engineered Bacillus anthracis, they don't clump together, so there's a greater chance of individual endospores getting deeper into the lower respiratory system, increased chances of pulmonary anthrax. There was an attack, 2001, some psycho idiot decided to mail Bacillus anthracis, powdered. It was carried on, I forget what powder he used, baby powder or something like that, talcum powder, that was laced with Bacillus endospores. 22 people got anthrax. 5 people died. Diagnosis. You have to have a reason. Okay, somebody's been exposed or they're showing symptoms. This usually isn't going to be top of the list, something that people really look for. Clinicians are really going to look for. Bacterium in the blood is a good reason to look, think septicemia. I'm going to have to look at gram stain to determine, gram positive, gram negative, cocci, bacilli, and it's going to take quite a few leaps before you come to the conclusion Bacillus anthracis. If it's suspected, blood samples, sputum samples, bloody sputum samples will be taken and sent to the CDC, and the CDC will do what is referred direct fluorescent antibody tests. Basically, they have antibodies to proteins on the surface of Bacillus anthracis. They will do a blood smear or a sputum smear. They'll heat fix it, and then they'll put the antibody solution on it. Antibodies will bind only to Bacillus anthracis proteins, the proteins on the surface of the bacterium. The bacterium's not there, antibodies won't bind to anything, they'll just rinse away. Look at it under a fluorescent microscope, basically a microscope with a UV bulb, and all the bacterium, all the Bacillus anthracis bacterium will glow green. If it's not Bacillus anthracis, it won't glow. Now, we do not vaccinate everybody for anthrax because, well, there's 350 million people, okay? That's just way too many people, and for most part, people aren't going to be exposed. So what they do is they pick and choose who has the greater potential for being exposed. people in the military, because some of the places we go, they don't hold to the Geneva Convention, hold to the whole, bio or chemical weapons agreements that we have. So they may use it. So military people will be vaccinated. Veterinarians, because they're going to be out and about, working with livestock and going to be exposed just like some farm workers will. Why don't we just go ahead, bite the bullet, and vaccinate everybody? Well, because it takes 5 inoculations spread out over a year. 3 or 4 of the injections just won't work. You have to have all 5, and then you have to go for annual boosters. So the logistics of that is just not there. So the vaccine, purified toxoid, they go through, they take the tripartite toxin, break it into its individual parts, and that's what they inject. The individual portions, if they're not together, will have no effect. Okay, they have to be attached together, working in concert to have the toxin capabilities. In a clinical standpoint, if you think your patient has been exposed or may have it, prophylactic antibiotics, okay, doxycycline, ciprofloxacin, IV, go ahead and start those. Take blood, take sputum. If they're coughing and hacking, so you think it may be pulmonary, collect sputum. Some talk about which sputum is best. Anytime they can cough up some bloody chunks, that's what you take and send. Other clinicians, for some reason, think that the first one of the morning, okay, you remember how it is. You wake up and you know, if you're cold, you're sick, you wake up from being laying down, that first few breaths of the morning as you're awake, you're going to cough. You're going to try to loosen up phlegm that's settled overnight. Well, as they're coughing and doing that, they're going to be coughing up chunks of lung material. And in those chunks of lung material, there's going to be a lot of bacterium. Send that off to ID lab with all the appropriate warnings that, hey, this could be anthrax. Send off to CDC, because anthrax is one of those where even if it's cutaneous or pulmonary, the CDC always wants to know, because this is one of those diseases they keep track of and they want to be notified immediately.